This is Algebra 2, Chapter 2, Section 2, in which we will study linear equations, linear relations, and functions. We've already talked about relations and functions a few times. Now we're going to get into a special type in which everything comes out as a straight line. When the graphs are straight lines, they are called linear relations. And the ones that are not straight lines are called non-linear. Imagine that. Something that is not linear is called non-linear. And then if you have an equation whose graph is a straight line, you'll be surprised by this. It's called a linear equation. One of the things you're going to be asked to do here is to decide whether an equation is linear or not. So we're going to look at some properties of linear equations. The first rule for a linear equation is you cannot have a variable in the denominator. Now notice this does not say you can't have fractions in a linear equation. There could be fractions, but the variable can't be in the denominator. A number can. That's okay. It cannot be a variable in the denominator. You can't have any powers other than 1. So no squares, no cubes, no 15th powers, nothing beyond a 1. Nothing other than a 1. You're not allowed to have radicals in a linear equation. No square roots or cubed roots or any other roots. And you can't have variables multiplied together. You can't have an x and a y in the same thing. 4xy would make it not linear right away. And there's one piece that I like to add to the list that most mathematicians wouldn't talk about, but I think it's important to note that you can't have more than 2 variables. You could have just x, you could have just y, you could have x and y. But if you get into a third variable, now you're talking 3-dimensional space. And for our purposes, that's beyond a linear equation. Now, if we have a function that has ordered pairs that satisfy a linear equation, you'll be surprised. That's called a linear function. Linear functions are just like linear equations. The difference is they'll have an f of x instead of a y. A lot of times you can use y and f of x interchangeably. It's not technically the same thing, but for our purposes, for the math you're going to be doing for the most part, you can think of f of x being the same as y. Again, it's not exactly the same, but it's close enough for your purposes. Now, your typical linear function is going to be written in the form f of x equals mx plus b. This is a variation on y equals mx plus b. It's the same idea. So the question that's going to be thrown at you is to decide whether or not you have a linear function in front of you. Okay, linear functions have the same rules as linear equations. No denominator variables, no powers bigger than 1, no variables multiplied together, and no radicals. So if they give me f of x equals negative 3 halves x plus 1/3, I don't have any variables in the denominator. I don't have any radicals. I don't have any squares or anything. And I don't have an xy together. So this meets all the bill, all the descriptors. So this is, in fact, a linear function. Okay. If we have 5 over x plus 6, we have a problem. We have a variable in the denominator. So no, this is not a function, not a linear function. It is still a function, just non-linear. What about our last one? We have f of xy equal to 3xy plus 1. We've multiplied variables together. That's a no-no, so the answer is no. It is not a linear function. Okay. When we write linear equations, there are several different forms. One form that we're going to really be interested in is called standard form. And the way standard form is written is to be written as ax plus by equals c. A, b, and c are both numbers, or all three numbers. Now, when you're in standard form, and this only applies to standard form, ladies and gentlemen, but standard form has a few special rules. You're not allowed to have decimals or fractions, so you're going to have to take care of those. You're not allowed to have common factors, so reduce if you can. Your a term, your leading term, can't be negative. You have to start an equation with a positive term. And then finally, you can't have both a and b both equal to 0, because if a is equal to 0 and b is also equal to 0, then you don't have anything over here. You have 0 total, so that can't happen. One or the other of them can be 0. You could have a as 0, so long as b is not. Or you could have b equal to 0, so long as a is not. They just can't both be 0. So let's write these equations into standard form, and then we need to identify a, b, and c. And they give us 2y equals 4x plus 5. Well, the first thing we need to do is get the x and y on the same side of the equation. Right? X and y are together, so we need to move the 4x over. It's a positive 4x, so we need to subtract to get it to the other side. So negative 4x plus 2y equals 5. But we have a problem in that the leading term, the a term, is negative, and we can't do that. So I'm going to multiply the whole thing by negative 1. And that gets me 4x minus 2y equals 5. Now we're ready to identify a, b, and c. A is 4, because it's what's on x. B is negative 2, it's what's on y. C is 5, it's over by itself. Then we have this one, 3x minus 6y minus 9 equals 0. The x and the y are together, that's good. But the c term needs to be off by itself. And the c term is not off by itself. So we need to move it. It's a subtract 9, so we need to add 9 to move it over. 3x minus 6y equals 9. Okay. Now there's a common factor in this. All of these terms have a certain value in them. They can all be divided by 3. So we need to divide each term by 3 to get to our standard form, x minus 2y equals 3. Now we can identify our a, b, and c. A is 1, b is negative 2, and c is 3. Last idea we need to talk about here in this video is to talk about the idea of intercepts. The point where a line crosses the x-axis is called the x-intercept. Point where it crosses the y-axis is called, surprisingly, the y-intercept. Now another way to think of x-intercept, the x-intercept occurs when y equals 0. The y-intercept occurs when x equals 0. So we're going to find a couple of x and y intercepts. So to do that, first I'm going to find the x-intercept. I'm going to put in 0 for y. Well, if I put in 0 for y, 3 times 0 is 0. So I've got a total of 8 right there. 0, that's nothing. So 2x plus 8, I'm going to subtract the 8 over, get negative 8. So x is negative 4. That's the x-intercept. X equals negative 4. When x equals 0, to find the y-intercept, I've got negative 3y plus 8 equals 0. Again, subtract the 8 over. Negative 3y equals negative 8. And dividing that gives me 8/3, or you could say 2 2/3. That's the y-intercept. Okay. One more, we have 5x plus 2y minus 10 equals 0. If I want the x-intercept, then I need to let y equal 0. So I put in y equals 0. 2 times 0 is 0. So I have 5x minus 10 equals 0. Add the 10 over. 5x equals 10. Divide by 5 and you get x equals 2. So that's your x-intercept, x equals 2. If x is 0, 5 times 0 plus 2y minus 10 equals 0. Move the 10 over, we have 2y equals 10. So y is 5. Your y-intercept is 5. Okay, we talked about linear equations, linear functions. We talked about standard form. And then we talked about intercepts. And as always, hopefully, if you had questions along the way, you wrote those down so you can bring them in. And we will see you in class.